Hello, welcome to first lecture of C programming course. In case you have missed the course introductory video, you can watch it on the main page of the course, and you can uh, get to know about that how this course is going to be followed. This is the first lecture of C programming, and we cannot start C programming unless you know some basics about computers and algorithms along with the flowcharts, right? So we will be starting with the introduction of uh, computer, how this whole setup is all about, and then we proceed to algorithms, and then we will be going toward flowchart, what symbols are used, how it is beneficial, and in more videos in the coming videos we will be also discussing about how these flows charts can help you in designing the algorithms for your problems, right? So first we start with the very first thing, that is the computers. Now if you talk about computer, it is just a general purpose device that can be programmed to carry out a set of arithmetic and logical operations. If you talk about arithmetic operations, they are something like addition, subtraction, division, then multiplication. These are the four questions. These are the four basic operations which you perform as arithmetic operation, whereas logical operation is just like comparisons, right? It can be greater than, it can be some sort of you can say uh, less than, equal to, greater than, equal to, something like that, not equal to, right? So these are the set bunch of things which you can add with the comparisons, right? So arithmetic and logical is all about these operations. Now whenever you talk about you know programming to be carried out on computer system, you always talk about certain type of operations which have some kind of sequence, right? Without sequence there will not be uh, a sensible output, right? So for getting a correct kind of output, you need to have some sort of sequence for your operation, right? So let's say if I want to add two numbers, right? So if I say I want to add two numbers, like let's say 5 plus 4, then what I require for this particular operation is, first I need this number, then I need this number, and for adding these two particular numbers I need a symbol, that is a symbol of addition, right? So this is what is required. So this is some sequence. You need to enter 5 in your computer, then you need to enter 4 in your computer, and then the addition will take place and the result will come as 9, right? So this is the basic, you can take it as a basic example of sequencing of any operation, okay? Then next thing comes out is that every computer consists of one processing element, which is generally known as CPU, also known as central processing unit. Now this central processing unit further consists of two things. One is arithmetical and logical unit, and one is control unit. Now these two units have very different uh, type of work, right? This unit is only responsible for performing these operations, that is addition, subtraction, division, multiplication. This is for arithmetic unit, and this is the job of logical unit, right? So these are two different set of operations which are performed by two different units, and to maintain the sequence of any kind of operation, control unit is responsible for this particular thing. We will go in detail in next slide, but you just need to take care about that. Arithmetic and logical unit is responsible for performing the operation, where a control unit is basically used for supervising, okay? Now, next thing which makes a part of computer is input and output devices. Yeah, right. So you all know about how keyboard, mouse, these are the input devices, whereas monitor, printer, plotters, they are the output devices, right? Along with this, you require some sort of memory. It can be a primary memory or it can be a secondary memory, right? So there are two types of memories, primaries and secondaries. So primaries are volatile, secondaries are non-volatile. So you can read about these things over internet or in some fundamental book, right? So I'm not going in detail of all such things. So my main motive is to just to get to just to tell you about that, what is a computer, why it is used, what are the main components of this computer system. Now, if next thing if I talk about is the block diagram of this whole computer setup, right? So any computer which you will work upon will have this basic setup, right? There will be some input devices, there will be some output devices, right? From input device, user will put data in computer, right? Whereas in output devices, uh, data will be displayed to user, right? So they are basically they both devices act as an interface between user and computer, right? So they are just the intermediate things between computer and user, right? Now next part is these are the components which are more responsible for performing different types of jobs or processing different types of data which user had input, right? So as we already discussed that this is the unit, that is arithmetic and logical unit, which is responsible for performing any type of calculation, and comparisons, or we call it a logical operation, which is basically comparisons, right? So it can be greater than equal to, it can be equal to, it can be less than equals to, it can be less than, it can be greater than, it can be not equal to, right? So there can be any number of operations which are responsible for comparisons, right? So logical unit will perform such kind of operations, and any of the calculation is performed by the arithmetic unit. But how they get this unit get to know that I need to do a calculation or I need to do a logical? So every operation which is to be performed by this particular unit first go through this control unit, right? So what control unit does for the whole CPU is it first check that what kind of instruction it is, what kind of data is required for performing that particular instruction. So as in last slide we talked about 5 plus 4, right? So we need an output of 9. So what kind of operation is to be done? Addition. So control unit will instruct the arithmetic unit to perform an addition operation. Now for this, data is required which may be sent by the user or may be existing in either external storage or the main storage. So control unit will pass on such signals to arithmetic unit that these are the two numbers which are to be added, and the result is to be either stored in memory or is to be displayed on the device. So control unit is, you can say, as a brain of computer system, which is responsible for performing all type of operations and is responsible for managing whole process of execution of any instruction, right? So this is the brain. This is the another subset which is responsible for either calculation operation or logical operations, right? So these two units which are attached to the control unit as well as the arithmetic logical unit, these two units basically assist this whole setup to to maintain or to store data either during the execution process or after the execution process, right? So if during the execution process data is to be stored, this the data will be stored in this particular memory. We call it a primary memory, right? Whereas once the execution is over and you still want to store your data, the data will be stored in your external storage, and this is also known as secondary storage, right? So this is your whole setup, which has the input output devices, which is also known as peripheral devices, a brain, which is a control unit of the central processing unit, an arithmetic and logical unit, which is responsible for calculation and logical operations. There is a primary memory which stores the data during the execution of any instruction, right, which is undergoing the execution process, right? And external storage, which is also known as the secondary storage, is responsible for storing the data which is to be stored for further reference even when the execution of the instruction is over, right? So this is what we have for a simple computer setup, right? So these are the main components. So you need to remember that control unit is basically responsible for sending across all these instructions to arithmetic and logical unit, depending on what type of instruction it is, right? So overall, if I want to summarize it as, so computer is basically a machine that manipulates data according to a set of instructions. Now these set of instructions will be named as computer programs, which you may heard about in day-to-day language, right? So whatever instructions are there, when a bunch of instruction is made, a sequence of instruction is already defined, so that becomes a computer program, and that is responsible for performing some sort of task for user. Now this computer program consists of different type of instruction. It can be any type of instruction. Let's say it can be a load instruction, it can be a save instruction, it can be some kind of arithmetic instruction, it can be let's say some sort of logical instruction, etc. Now, as we proceed in this course, we will be talking about all kind of instructions. So like if I say arithmetic instruction, so I am talking about this. If I say logical instruction, I am talking about is 5 is greater than 4. If it is greater than 4, then say 5 is greater. If not, 4 is greater, right? So in this case only 5 is greater, so this is of no significance, right? So basically there can be different kind of instructions in a program, right? So it depends upon what kind of problem you are trying to solve using your computer program. Now each instruction triggers a sequence of simple action taken as either addition, subtraction, division, comparison, etc. So as we already discussed, these are the arithmetic operations and these are the logical operations. Now the collection of any computer program, let's say 10 computer programs are there and we made a collection, and each of the program is responsible for doing some job. Now when we combine them together, that becomes a computer software, right? So like I'm working on this PPT right now. So this PPT is basically what? This PPT is basically a computer software which is responsible for, which is taking care about a lot of things which you may be not aware about. Like I'm writing on it, I'm moving from one slide to another slide. So each program will be responsible for doing each of the particular task, right? So there may be specialized for each type of step. So best examples are operating system, video games which you play. You press left button, that character moves to left. If you press right button, that character moves to right. So each button press is programmed for some particular type of job. Similarly, MS Paint, you draw something in your MS Paint software, so that each action has some sort of individual computer program which are combined together to make a computer software named as Microsoft Paint, operating system, video game, etc., whatever you want to say, right? So basically, this is what we have. So whenever we are going to start with C programming, we will be talking about the basic programs one by one and one. Once we are, good enough to write bunch of different programs, and we will be working on some project which work as a software for the computer, right? So this whole thing will be covered in later lectures of this particular tutorial. So overall is computer is a machine which is responsible for running certain type of instructions and manipulating the data according to the need of the problem, right? So any computer program requires a blueprint. Now this blueprint is basically named as an algorithm, which actually defines that how your program sequence will go through. So if we talk about more technically, we call this as a algorithm, right? Now there are a bunch of definition which you find about the algorithm. The very first thing which I picked from the dictionary is, it says a set of rules for solving a problem in a finite number of steps. So it is very important. Certain rules you define for solving your problem, but there must be a finite number of steps, right? Now, second thing comes from author Thomas H. Corman. He's an author for Introduction to Algorithms, which is MIT Press book, right? So it says an algorithm is any well-defined computational procedure. So you say computational procedure that takes some value or set of values as input, process them, and produce some value or set of values as output. So it says input is there as well as output is there, right? Next, I picked it from Google. So Google says a process or set of rules. Now, procedure is a process basically, and set of rules both are included here. To be performed in calculations, a process or set of rules to be followed in calculations or other problem solving operations, especially by a computer, right? So overall, it may be a process, it may be a set of rules, which is basically for problem solving operations, right? So from all these different definitions, we can conclude that algorithms are set of well-defined steps to solve a defined problem corresponding to provided input. So that means there are some inputs provided corresponding to problem, right, which is to be solved. So there will be a number of steps to solve this, right? So if I go further, any algorithm will have these 5 things, right? You require input, accept 0 or more inputs externally. It will be provided by user. We will see in next few videos, maybe in second or third lecture, that how user provide input to this algorithm or the program which will be designed by making base of this algorithm, right? Now next, output. And every algorithm must produce at least one output, right? At least one output is required, whereas 0 input can be there, okay, as a result of procedure you have. Now definiteness. Now definiteness says that each instruction must be clear and unambiguous. So that means every instruction must be easily understandable, right? And it must have a definite purpose, right? So let's say if I say I want to divide 5 by 1, so it says that division is to be done. 5 into 4, it says multiplication is to be done, right? So something like that. Finiteness. As per finiteness, it says if all the instructions are traced in algorithm, then for all cases the algorithm must terminate after a finite number of steps. So it must stop must stop after finite steps. If it doesn't stop, that means there is no use and no output will be produced. So if there is no finiteness, that means this program or this algorithm is no use for us. Okay. Next is effectiveness. Now every instruction must be very basic so that it can be carried out and must be feasible to perform on any machine. This is a little bit technical. When you start working on C program, you will get to know that there are some expressions which are very complex, right? Now if you go and perform an expression like this, 5 into 4 divided by 2 into 9 into 10 divided by 5 into let's say 8, and let's say this has a modulus operator 2 plus 5 plus 10 and so on. So for you it is little bit difficult to read. You cannot guess the answer unless you're not aware about the BODMAS thing, right? BODMAS formula, right? On the similar pattern, computer also works on a certain level of precedence, which we will learn in later videos, right? So effectiveness, when I talk about, is it must be feasible, right? It must be very basic. So if I say I want to perform an operation, this is a basic operation. Then once I get a result of this, then I will divide the result with 2 and so on. So these are the basic operations which I perform. Whereas this expression is a very complex expression. Even though this is not difficult for computer to solve, but with the perspective of a programmer, we need to make our code effective, right? So we need to simplify this. Okay, so this is why we say effectiveness. Okay, so these are the 5 properties or characteristics you can say an algorithm must have: input, output, definiteness, finiteness, and effectiveness, right? So if you achieve all these 5 characteristics, so that means your algorithm is algorithm for a computer program or a computer problem is on the right track, right? So if I design any algorithm, so I need to keep few things in mind. So first I need to understand that algorithm is not a computer program, because computer program is written in some particular programming language, right? Whereas algorithm is either written as a pseudocode. Pseudocode is something like combination of English and expressions, or it can be written in purely English language with the type of some description, right? Second thing, algorithm only provides information about what calculation are to be performed and in which flow. So you need to tell about the calculations. What calculations? Like if I say I want to perform addition, subtraction, and then addition. Okay, and the flow must be like subtraction, then addition, and then again addition, right? So first you specified what operations are to be performed and then in which flow they must be performed, right? So we will see in examples of this algorithm, like if we want to add 2 numbers, we can have algorithm as ask user to enter 2 integers. Now this is an English language type algorithm. Now first step is you must have 2 integer numbers, right, to add. Okay, so you need to ask user to enter 2 integer number to provide 2 numbers, right? Now next step is to add both the numbers, right? So let's say user provided 4 and 5. You added 4 and 5 and you get the result 9. Now finally you need to provide some output, right? So you need to print the sum value of the 2 numbers, and that is 9. So you print 9 at the end of the algorithm. So you specified that this must be flow. First ask user, then add, then print. You cannot say that first before asking user for two integer number you can add two numbers, right? So this flow is to be maintained, otherwise there is no mean for this algorithm, right? So this is the one type. Second type is pseudocode algorithm. Now this algorithm is little bit technical. You write algorithm and the name of the algorithm. So I said this algorithm has a sum, right? Then you need to specify that what input is required and what output this particular algorithm will produce. So input is two integers and you have specified that 1 and 2. Whatever the integer number you put, you name them as 1 and 2. So let's say 5 and 4. So 5 will be as first number or 1. 4 will be as second number or 2. Now output sum of 1 and 2 as result. So whatever the sum is will be done from these two numbers, that will be stored in your result and printed as result. So next step is the actual process. So you take user input, put that in 1. So that means you take 5 as input from user and put it 1. Similarly for 2, you take 4 as input and put it in 2. Now you sum or you add 1 and 2, that means 5 and 4, and save the result in save the sum of these two number in result. So that means at this point of time result will hold 9 number, and at the last you return result. So return means you are giving user with the value of result result name. So this result will hold the value of 9. So that means user will get 9 as output of this particular algorithm. Similarly, you can show the you can display it as a diagrammatic representation. So we call it as a flowchart representation. In this we have some specific symbols. We will study about these symbols in next few slides. So for your reference only, like we were adding two numbers, so we say enter integer 1 and get it from user, enter integer 2, get it from user again, add 1 and 2 and put the sum in result, and put here says that you want to print it on your display screen. So result is the value which is stored in result, right? So it will be displayed as result is 9 if you take the values if you consider the values 5 and 4 as for 1 and 2 variable, right? So this flowchart will basically a flow of algorithm which can be represented using flowchart. Such representation is used for easy understanding of algorithm by everyone, right? So this makes easy understanding. That is very important point. Now next thing comes is the flowchart. Now if I talk about technical definition of flowchart, then I say flowchart is a type of diagram that represents an algorithm or process showing the steps as boxes of various kinds and their order by connecting them with arrows. So if I consider this particular diagram, so it has a flow, right? Next thing it says represent the algorithm or process. Definitely this particular flowchart is representing an addition process, addition of two integer numbers, right? Then it says showing the steps as boxes of various kinds. Now if you see boxes of various kinds, this is a palindrome, this is a palindrome, and this is a rectangle, and this arrow says input and this type of arrow says output, right? So each symbol resembles something. So this rectangle is basically used for calculations, right? So this is input, this is output, this is for calculation, and this Oval shape is for starting and ending representation of your flowchart, right? So if I come to the basic notations which are defined as standard, oval is used for denoting the beginning and end of the program like we have described here. Then flow lines is basically used for connection or defining the logical flow of the program. Like if I come to that flowchart again, so it says this is the arrow, this is the arrow, this is the arrow. So this is defining the flow, right? Now next thing, parallelogram. This is used as either input or output operation, right? Next, rectangle is used for process to be carried out. So here whatever the calculations are to be done is defined in this, right? Next is diamond. We haven't used it here. There is no use. Why? Because there is nothing to decide in this particular algorithm, right? So this diamond is only used for decision purposes, right? And it works on yes or no basis. If let's say is a result, let's say we need to check that is the result is okay, result is greater than 10 and put it in diamond. This side is no, this side is yes. If the result is greater than 10, we say hooray. If the result is not greater than 10, I say very bad, right? So when we need to decide upon something, some criteria, we have, as we said, if result is greater than 10, we say hooray, that means an expression of happiness. Whereas if it is less than 10, then we say very bad, which means an expression of sadness, right? So for exampling such kind of such kind of problems, we use this diamond shape symbol, right? So this is used for decision purposes. So these are the symbols which are required. So if I want to share with you about the different tools which are available for openly for anyone to use, one is the Raptor. This is one of the open source tool which you can use, and I will be discussing about this in next video, and I specifically dedicated a full video for this particular tool. And this is a very important tool. You can start your problem solving using this tool, and this tool is purely based on flowcharts. So that means before writing programs, you learn how to solve your problems using this flowchart technique, right? Then is Liquid Charts. This is a web-based tool. Then is Microsoft Visio. This was bundled with 2007, but it is now discontinued. But still, it is a very good tool to start learning about the flowchart based schemes to solve your problems, right? But this is one of the tool which is used by lots of beginners, and it is very easy to use as compared to these two tools. So I will be stressing upon this, as this is free of cost and open source, so there is no issue of copyright for me as well as you. So we can download it. I will be providing the link for this tool in the description of my video page, so you need not to care about that from where to download and all, right? So this is what we had. Now I took every material from these references. One is from the same website of our Superbits Academy. It was another course, design analysis of algorithm, and you can check the detailed part of this particular lecture. Then I took some part of my PPT from Willy. Then I use symbols from there, and then from wiki, a basic of computers I picked up, right? So you can go to these reference websites and you can check the basic uh, text which I have used in my PPT, right? So at the end, I request you to to write an email to me on hello@superbits.com if you have any feedback, any suggestion regarding my lecture. If you doesn't like the way I deliver these tutorials, these video tutorials, and if you want some kind of improvement, you can suggest it on, and I will try to club it in my lecture, as this is the first kind of lecturing methods I'm trying to include, right? So you can just write feedback, FNC programming as a subject, and send your feedback and suggestions to hello@superbits.com, right? And I will really appreciate you if you share your feedback and suggestion, and I definitely include in my next coming lectures, right? So thank you very much for watching this lecture, and in case if you find this lecture helpful, do share it with your friends. Thanks a lot. Bye bye.